Gregor, I might help you or not help you. It's Vesa Kanyainen from University of Helsinki. And I had contact 20 minutes ago with him, you know. He was playing around a little bit with Eastern European time and Central European time and summertime. I don't know whether he solved the problem. Obviously he didn't, you know. So I suggest, you know, that Ken will do his talk, and then if Vesa finds out, you know, that he is in the Eastern European summertime, then he could maybe give the introduction afterwards. Well, we don't have a big problem here because Ken is well known, you know, so it's everybody knows his work and, you know, and all the ideas he has, and so we are actually looking forward to the new ideas now. And yeah, and then when Vesa is around, if he is around, you know, then we just put him in, I guess, in the end.
Okay, can everybody hear me?
Yes, we can hear you very well.
All right. I can't see the audience anymore, but I will try to work alongside Gregor and ask him to change the slide. So you know, the title of this talk, very ambitiously, is Thinking About Social Norms. And there's a discussion paper that I wrote that some of you may have. If you don't have it, you can email me at my address that the little cartoon character is pointing to, and I will send you. Actually, really thinking about social norms is much too big a subject for a 1 hour talk. So I've got a subsidiary title, Let's Not Throw Away Homoeconomicus. One hears all the time, Homoeconomicus, let's get rid of him. And he's very valuable. And this way of thinking about social norms most certainly needs Homoeconomicus. I've got a cartoon now, Gregor, of Homoeconomicus and the market. Have you found that?
That's what you can see.
Yeah, usually people who are hostile to Homo economicus imagine that his proponents want to model the whole world as a market, and he's quite useful when modeling markets, but that's not the reason I'm arguing here that we should keep him. Next slide. I found it on the internet very easy, kind of jokey reference to Homo economicus. It says 100% rational. And the kind of Homo economicus I'm defending here, yes, 100% rational. The second arrow says 100% focused on money as an incentive. And no. This isn't, this is the thing that's made up by Homo economicus's enemies, the behavioral economists and people on the very right wing. Textbooks don't say Homo economicus is focused on money as an incentive. This is just an invention. It's true that Homo economicus maximizes his own utility, but nothing says that his utility can't depend on the welfare of other people. And one can use him for that purpose very, very easily. But in fact, the big success of Homo economicus is not in markets, it's not anywhere in economics, it's in evolutionary biology. The little picture you've got, I hope now, of an ant, Acromyrmex versicolor, that's taken out of a paper of my own, applying game theory, the model of Homo economicus, to ants. And ants can't think, not in any way that we think in any case. So how can it be useful to have a model 100% rational of players that are going to represent ants. And this is what I hope to explain for a little while. Probably people here mostly old enough to remember the old pop song that went, "Why do birds sing in the early spring?" And the context of the song makes it obvious it's because the birds' sex hormones are circulating. And that's what we might call, or what biologists call, approximate explanation. You could add to the sex hormone explanation by saying, well, you know, this molecule had to knock against that molecule, this enzyme had to catalyze this reaction, and so on and so on. So, you know, approximate explanations are very difficult and complicated. But they're not the only kind of explanations that matter. And in biology, evolutionary theorists are mostly interested in ultimate explanations. And an ultimate explanation isn't just how come, what caused it immediately to happen. They're about why it happened, the reason that it happened. And in the case of why do birds sing in the early spring, the ultimate explanation is that birds that didn't survive. It's a survival characteristic, part of the strategy that keeps these birds maximally fit. So the ultimate explanations, for which we need Homo economicus, as I'm going to explain, and there are approximate explanations, and we certainly need a better model than Homo economicus there, but it doesn't mean, therefore, we can dispense with Homo economicus altogether. We need Homo economicus when we're talking about ultimate explanation. So next screen. I hope you can now see a picture of a game, a 3x3 game. Red picks a row, and blue picks the
battery
column.
high.
And I guess everybody's seen such a thing, so I'll just move on and show some Nash equilibrium. So in the okay, is that someone telling me I'm out of phase with my okay, well, I can hear noises, but I'm just going to continue. In this picture, blue has chosen her first column, and red looks at it, and you can get a payoff of 2, a payoff of 4, or a payoff of 3. 4 is best. So this strategy, his second strategy, is his best reply to blue's first strategy. Equally, if red chooses this row, what's the best reply? Player 2. Player 2 can get 0, 2, or 3. 3 is biggest. So this column is the best reply to this row. So we're looking at here at a Nash equilibrium, which means each player is making a best reply to the other. And the point of this picture is really that there are at least 2 Nash equilibria here. There's this Nash equilibrium, and there's this Nash equilibrium. And there's always a third one. Nash equilibria come in odd numbers. Here it's in mixed strategies. But this is absolutely standard that nearly all games have many Nash equilibria. And what are we going to do about that? What's our prediction of what happens in a game going to be when we've got multiple Nash equilibria? And next screen. And here is the way we think about this problem when we're modeling the players as Homo economicus. We've got a male player playing red. I've got a blue player playing column. And they think and they think. They come out with a solution. Now, what is that solution? Well, the minimal thing it can be is a Nash equilibrium. If it wasn't a Nash equilibrium, why would one of the players play it? Because he or she would have a better thing to do than play what is supposedly the rational solution. But in here, there are two possible rational solutions. There's one here, 4, 3, and there's another, 2, 2. This is what we need social norms for. We need a social norm to choose to pick amongst Nash equilibria. But when we're thinking about social norms, the last thing we need is Homoeconomicus. And then we have to turn to the other interpretation of a Nash equilibrium. This is the evolutionary interpretation. So I hope you're looking at a picture now with the rational interpretation on the left and the evolutionary interpretation on the right. And the evolutionary interpretation of a Nash equilibrium is that two animals, or two people for that matter, have played this game over and over and over many times, and they've adjusted their strategies over time, moving always in the direction of higher payoffs. And when can such an evolutionary process stop? And the answer is it can only stop at a Nash equilibrium, because only then can the players not increase their fitnesses by varying their behavior. So again, this evolutionary process could lead to the Nash equilibrium 2-2, which I've indicated in the picture, but it could easily have ended at 4-3, the alternative Nash equilibrium. But at least in the evolutionary interpretation, we've got some understanding of why one equilibrium was chosen rather than another, which is completely absent in many, many games. So I want us to think about Nash equilibria, what they are in terms of Homo economicus. Homo economicus model predicts what the possible outcomes of an evolutionary process might be without having to know all about the evolutionary process. He's very useful for that purpose. That's what mathematical biologists use him for. All of their models are actually of Homo economicus, and only very seldom is the actual evolutionary process looked at or modeled. And we should now be on a screen with a diagram on the right of the game.
Mm-hmm. See it, yes.
Mm-hmm. Now, if one wants to think about possible equilibria in this game, it's useful to think of the players sitting down together and bargaining about which strategies to use. And if they can write contracts, and this is contracts which are obligatory, contracts that you can't cheat on. And the diagram on the right, the greenish yellow area, shows you all the possible compromises that might be made on which you might contract. And where it says Pareto efficient compromises, those are all mixtures of the two outcomes, 1-7 on the top right and 8-1 on the bottom right. So all the Pareto efficient outcomes are mixtures of those two pure outcomes, but they're unavailable without the ability to write contracts, because otherwise, if the arrangement isn't contracted, or at least one player has an incentive to cheat. And why shouldn't they cheat if there's no motivation for not cheating? So we're stuck with the two stars in the diagram, or the convex hull of those two stars. This is the best we can do without contracts. But when the human race got started, we couldn't write contracts, but somehow we managed to cooperate. And how did we manage? And the answer, the earliest version of the answer that I know of is due to the philosopher Confucius. He was asked by one of his disciples, what is the secret? How do human people manage to cooperate? And his answer was reciprocity. Much more elegant in Chinese because it's just one ideogram. Some Chinese scholars want to make it more complicated, but this is the standard translation. And game theory has this all sorted out, at least in a simple case. How do we model reciprocity? And to model reciprocity, we need repeated games. Because the essence of reciprocity is you scratch my back and I'll scratch yours. But if there's no future, how do I reward you for helping me? How do I punish you for not helping me? So we need indefinitely repeated games for this. And indefinitely because if there were a last game, people would have no incentive to cooperate in the last game, and then it would all roll back to the beginning by backwards induction. So we need an indefinitely repeated game with high continuation probability, so that the future really matters to both players. This is the simplest setting in which we can study reciprocity in game theory. So here on the left, it's the next slide now, Gregor. Here on the left is the picture of the indefinitely repeated game. And the copies receding into the distance is supposed to indicate that this future gets more and more improbable as time goes by. And this is the most important theorem, I think, for political science that there is. Political scientists usually laugh when I say this, but I genuinely think this. The Folk theorem says that as the continuation probability tends to 1, the set of all possible Nash equilibrium outcomes is what you could get if you could write contracts and sign an agreement at the beginning. The fact that you can't sign a contract in an indefinitely repeated game is no hindrance to achieving Pareto efficient outcomes. So in particular, all the Pareto efficient outcomes that we looked at before, they are available as Nash equilibria. So our problem is, which one do we choose? Far from having an embarrassment of not enough equilibria, like in the prisoner's dilemma, our problem here is that pretty much everything is available as a Nash equilibrium. And we'd like society to choose an efficient one, but which efficient one? And this is what social norms are for, or at least this is what game theorists think social norms are for. Social norms are there to help choose or to specify which of the many Nash equilibria society is going to play. The easiest case, of course, is the driving game. And that has a very simple game, just has 2 Nash equilibria in pure strategies. Everyone drive on the left, everyone drive on the right. And some countries choose one. Japan chooses always drive on the left. India chooses always drive on the right. Why is one social norm better than another? Well, people kind of invent reasons, but fundamentally, there isn't a reason. Why is it drive on the right in India? It's because of India's social history. Why is it drive on the left in Japan? Because of Japan's social history. So Homo economicus is no use for this at all, because Homo economicus doesn't have a history. Homo economicus just stands there by himself or herself. So to study social norms, we need something more, something other than Homo economicus, but we can't do without Homo economicus, because Homo economicus is the model we use to determine Nash equilibria on which a social norm, from which a social norm can choose. I know I'm dashing along, but I'm a bit concerned about teaching an audience of grandmas to suck eggs. I guess everybody knows most of this already. No, I'm looking at home at a different set of slides that you have there, Gregor. Can you click forward until we come to
contemporary problems? Is the next slide?
Can you click on until you come to a slide called punishment?
We have changing social norms.
Yeah, just click on and there's a slide entitled punishment. And then we'll come back again.
Yes, punishment. Okay.
All right. Now, you know, how do these Nash equilibria work in the indefinitely repeated case? And I guess everybody present knows about tit for tat in the indefinitely repeated prisoner's dilemma. And if both players use that in the indefinitely repeated prisoner's dilemma, and the continuation probability is sufficiently high, the result is a Pareto efficient Nash equilibrium. And why does it work? It works because if anyone deviates, if anyone doesn't do what they're supposed to do, they move away from cooperation, and that behavior is punished. This is why the strategy is called tit for tat. If you fail to cooperate in this period, your opponent will punish you by defecting in the next period. So the response to a tit is a tat. Now there's a problem in larger games, multi-person games, the kind of games played by a whole society, because in the infinitely repeated prisoner's dilemma, it's natural to assume that both players know what the opponent has done in all previous plays of the game. But in society as a whole, that's certainly not true. So it may be that somebody deviates from the social norm, and now the equilibrium says it's your job to punish that person. But suppose that punishment is costly, and to suppose even more, suppose nobody can see whether you punish or not. So you can secretly deviate and nobody will know. So there's a big problem there. There's another problem, lesser problem, but still a problem, which is why should you punish if it's costly? You're off the equilibrium path because somebody has deviated. You now have to pay a price to punish the deviant. Why should you pay that price? And for this purpose, we need much more than a Nash equilibrium. We need perfect Nash equilibrium. And in a perfect Nash equilibrium, the strategies used are in equilibrium even if you go off the equilibrium path. Even in unreached subgames, the strategies are still in equilibrium. And I tried to illustrate this with a little picture down below. If you look on the left, there should be a little circle with player one. And he or she can play down, which is to honor the norm, the green strategy, or player one could cheat on the norm. That's out of equilibrium, but what happens if player one does deviate? And then it's, according to the norm, it's player two's duty to punish player one. That's the green arrow pointing down. Well, that may be costly to player two. So player 2 may be tempted to deviate. So what happens if player 2 deviates? Well, then it may be player 3's turn to honor the norm by punishing player 2. But player 3 may deviate, and then what? Well, then it'll be somebody else's turn to punish player 3, and that may in fact be player 1 again. In fact, if there's a finite number only of players, it's eventually going to be repeated, that the player 2 will again be somewhere in this line. So this is the property that a perfect Nash equilibrium has that matters to us. As long as information is not imperfect, as long as one knows everything that's happened in the past, a perfect Nash equilibrium entails, if people use a perfect Nash equilibrium, it entails that nobody ever fails to punish when the punishment is required. This is complicated, I know, but it's worth paying attention to. Immanuel Kant thought about this problem, and he didn't consider the fact that the players may repeat, that these chains of responsibility may go round in a circle. And so he argued that to avoid an infinite regress, these red arrows have got to stop somewhere. And that person is the boss, in his case, the King of Prussia. But we game theorists don't hold with that. Now, the next slide, I hope, is called anger.
Yep, there's a monkey,
Got it?
a gorilla.
Yeah.
Chimpanzee, I don't.
Yeah, I looked long and hard for this angry gorilla. In fact, what's happened to him in the big picture is he's been excluded from some food sharing. And he's very angry, but he's not a boss gorilla and he has to put up with it. So this is how perfect Nash equilibria are sustained in real life. You know, gorillas are not examples of Homo economicus. They're not 100% rational. They don't think things out in the way I just explained. The mechanism for sustaining the equilibrium is programmed in to their psychology. If if someone deviates, and this guy obviously feels somebody's deviated from the norm, people get angry. They experience other emotions as well, which are significant, but the significant emotion for punishment is anger. The norm has been deviated. Who knows how or why? Who even knows that we're operating a norm? But this is a situation in which it's appropriate to feel anger. I feel anger. When I'm angry, I want to punish. And it's not just gorillas, of course. There's people too. So now I want to go back. Go on one more slide. It should say contemporary problems.
About trumpery?
Contemporary problems, it says at the top.
It was before, some slides before.
Yeah, it may be before. Yeah, turn on to before.
Here, contemporary.
While you're looking, I'll keep talking. This story of how social norms work is under really serious threat right now, almost entirely because of the internet, in my opinion. And there are two reasons, or at least two reasons. And reason number one is that the multiplayer folk theorem depends very much on the history of play being an open book. Nobody's got any secrets in the folk theorem, but people do have secrets in the real world. And we don't know how to cope with the problem, or at least we only know how to cope with the problem of lack of information for the folk theorem in restricted cases. You know, for example, last week Larry Samuelson was talking about this problem. What do we do if the history of play is not an open book? For example, on the internet, there are people called trolls. I don't know if that's what you call them in Germany. There are people who send abusive or threatening emails to other people. They're called trolls. And if it was an open book, if everybody knew who that person was, who that troll was, they would do the same to him or her. That's how reciprocity works. But we can't do that to a troll because we don't know who the troll is. And there are things in the computer science literature about what we could do about this, which I endorse. For example, I don't think anyone should get away with anonymity. You should have to be own up to who you are. And then there's a question is how can one enforce such a rule? Even worse is the second point. And you know, Nash equilibria are stable in the presence of deviations by individuals, which is fine. You know, when we were hunter-gatherers in groups of 100 or so, you know, each individual was identified. But they're seldom stable to deviations by whole coalitions, by large coalitions. But in the past, that didn't really matter very much. Well, more and more as communications improved. But originally, it didn't matter very much because you need big coalitions, and how do they coordinate? But now it's not a problem because we have the internet. And you know, since Donald Trump, we've learned how coalitions can be worked, can be manipulated. So I think both of these issues are really major issues, not just for how we model social norms, but how we maintain social norms in the future, because what is society if it's not the set of social norms that it operates? And I know there'll be people in the audience who want to say that's a big thing to say, and it is. All right. I'd like you to go back, Grabble, and see if you can find changing social norms. There's a picture of a shoal of fish and sharks.
Yeah.
What we're looking at in that picture is a social norm operated by fish. And you know, nobody thinks fish are any better models of Homo economicus than ants. It's obvious that the shoal is at least a local equilibrium, because if any one of those fish swims away from the shoal, it makes itself vulnerable to the sharks. So their incentive is to push in, and they're programmed to swim around, as you can see them swimming. There's not a unique equilibrium in this particular case. As you can watch, I guess we've all watched on television, shows of fish being hunted by sharks, sometimes by gulls of various kinds, and all kinds of fish come in for the kill. And while this is going on, the shape of the shoal varies and changes. And, so there are many, many equilibria, and you can see the system drifting between them. And there may be other equilibria which don't involve shoaling, but we don't see a picture of that here. And I'm trying to say that we need a model of Homo economicus to tell us what I just said about disincentives, why it's an equilibrium to have a shoal. But Homo economicus can't possibly help us in watching how the shoal works. The fish are programmed to behave in certain ways relative to the other fish about them. They can't do anything about it. That's just part of the way that the shoaling is sustained. And I'm trying to say the same for people. And people don't want to be compared with shoaling fish, but that's the sense of it. That's the essence of it. I want to say in this last part of the talk. Now I'm on to changing social norms. Gabor, there's a picture of a landscape.
Mm-hmm. Yeah, we have it.
Yeah, that's right, and it's taken out of a geography book, and you can see the various features on it. Biologists use pictures like this, not pictures taken out of geography books, but pictures drawn to represent certain biological situations. In their pictures, the fitness parameter is height, but it points upwards. I'm going to use this geographical picture, and you've got to think of fitness. You get more fit as you go down. So how does evolution work? Or how do you picture evolution working? And the black line, the black squiggly line is my attempt at this. It started somewhere up on a mountain, and gradually the population moves downhill. It's the whole population that's moving in these pictures. It moves, gathering fitness as it goes. There's a sudden catastrophic fall as it comes over the head of a hanging valley, which is quite common in game theory, incidentally. And then down below, this is quite important to me as well, you can see in the flat valley down below, the system drifts back and forwards. Now, each of these, in this picture, you can see lots of equilibria. Each of the little lakes at the top, up in the mountains, is a basin of attraction for an equilibrium. So there are low fitness equilibria up there in those little valleys. You don't need too big a perturbation to get the system out of one of those little valleys. But when they're deep, like in the glacial trough, it's very hard to get out. On the other hand, at the bottom of the glacial trough, that's more or less flat. So everything at the bottom of that valley, where it's flat, is an equilibrium. And the system can drift back and forward in that little valley. And this phenomenon is very common, not just in biology, but Larry Samuelson and I have a sequence of papers about this. And we were trying to find examples, reasonably complicated, extensive form games which didn't have this phenomenon. It's very difficult not to find it. So drift amongst Nash Equilibrium is a phenomenon we've got to expect. In Axelrod's simulations, you can see the drift taking place there amongst the competing strategies. The other way a social norm can change is if the landscape changes. In my terminology, if the underlying game of life changes, that might happen if there's a technological change. And we've had plenty of technological changes, and we've also had drift, in my opinion. One more thing, I find these landscape pictures very useful, but they're only really useful in biology in one-dimensional games, where there's only one parameter that matters. But in game theory, what biologists call game theory frequency dependence. A picture like this would be like an Escher picture, in which you can go down and down and down, and then find yourself at where you started. So a game theory picture like this, a genuinely game theory picture like this, would be much more difficult to draw. It would still have drift. All right. I'm nearly, you'll be pleased to hear, I'm nearly over now. Because what I wanted to say at the end was something about populism. And we have this great word in English, trumpery, which might have been chosen for the occasion, but it's a very ancient word. What it means is something that looks very good but is useless, something that glitters but is not gold. And it fits so well, trumpery, that what a shame not to use it. What's happened in my picture, have we got the picture with trumpery at the top?
Yeah, we have.
Yeah.
Mr. Simpson.
What you can see in the picture is in the past, the red spot is what the social norm used to be. That's the social norm that people are accustomed to. It picks a Nash equilibrium in a complicated, repeated game. And people know how to play this equilibrium. They learned it from watching other people when they were kids. It's been in place for quite a time. And they know that it's appropriate to get angry if someone deviates from the norm. And when you're angry, you look around for someone to punish. And you can see, what's his name? Bart Simpson is, he knows the social norm should be red. That's the social norm. And he wants to punish someone because he's angry. And the ultimate reason that he's angry is that there's been a social norm shift. And in the picture, the social norm has drifted from red to blue, but it could have been that the game has changed. There's been an earthquake of some kind. And so he sees people operating the new social norm, and he thinks they're deviants. And what kind of deviants are they? And I've got a bubble on his head. This is the kind of thing that blue-collar workers like Bart's father think. They see they're being left behind. They're not needed in this new norm. They're not respected in this norm. And who's responsible? Who are these deviants? And famous answers, popular answers, Washington insiders, taking graft, or Latino immigrants coming over the border taking a job. These effete wokists in taking over universities, or these people who irrationally don't care for white Anglo-Saxon Protestants. These are the people. These are the people that need to be punished. This is why we vote for Trump, because he seems to stand for us. And what about us? What about the university folk, so-called intellectuals commenting on it? And I read the New York Times every morning. I look at CNN. They've given up now, but for months and months, they were trying to explain to people who don't read their publication why the belief that Trump is putting around that the presidential election was a fraud is a big lie. There's no point in telling these people that this belief is a big lie. There's no point in showing them objective data that shows this. There's no point in listing the cases in court where the fraudulent allegations have been thrown out. All of this is a waste of time because the Bart Simpsons of this world don't care about that. They don't really care whether this belief is true or not. They're not specimens of Homo economicus. They don't look at their preferences and their beliefs and their maximized utility to obtain behavior. This is not the point of the big lie at all. What they're interested in is the behavior. They want deviance of who they imagine are deviants from the social norm. They want them punished. And we can do that by all getting together and exhibiting certain behavior. And how do we describe that behavior? Well, it's really quite complicated to describe all the appropriate behaviors. But, you know, in a bizarre reversal of neoclassical equivalence, let's all announce a belief, which, if we genuinely believed it was the truth, would generate the behavior that we want to see. So there's no point in talking to the people who vote for Trump. I do Bart Simpson a disservice by classifying him amongst those folk, but there's no point in telling him that his beliefs don't make any sense. He probably knows that the beliefs don't make any sense. He probably doesn't think the big fraud is very likely, but I'm going to go on as though it were true because I want to see the behavior that follows. What we have to do is abandon Homo economicus when talking to Bart Simpson. We have to talk the talk of psychology if we can, and I'm very pessimistic about the possibility. Anyway, to end on a more positive end, I'm very displeased when people propose to throw away Homo economicus. We need Homo economicus, but we don't need Homo economicus to understand Bart Simpson. People are absolutely right about that. If we want to understand Bart Simpson, we have to look at the proximate causes of psychology of his behavior, and Homo economicus won't help us there. But we need Homo economicus so we have a decent model in which we can study what counts as equilibrium, so that we can know what social norms are feasible and which are not. So I'm in favor, let's keep Homo economicus and let's replace him with whatever you think better when studying proximate causes, but we need Homo economicus for ultimate causes. Okay, I'm through here. I don't know if anyone's still listening, but I'm hoping so.
Okay, then.
Yeah. If our chairman has appeared, I'd be quite interested to know what he has to say.
Mm. Well, I think I should do a short announcement about Vesa Kanyainen. He sent me 5 or 6 emails, and I sent him 3. Well, unfortunately, it was this wonderful talk. There's a problem. Technical norms. No? Technical norms fail sometimes. And here we seems that we have a case, where it really happens. So Vesa is out of equilibrium. He's very sorry. But he has a written version of his comments.
I was out of equilibrium too. It's only by a very low probability event that we managed to communicate. Anyway, I'm happy to answer questions if there are any.
Okay. So, Gregor, are you managing the discussion? Because you have the technology there.
Yeah, I'm just asking around, and everyone is unmuted now, so we can all pose our questions. And if anyone wants to contribute to the discussion, just raise your hand. It's a camera. Can I see you?
It is a hand.
John Maymark raises his hand.
Kaushik Basu has a paper that I think he presented last year in the seminar, where
like, how nice to hear your voice.
Yeah, thank you. Like you think about Schelling's focal outcomes, and he switches it to thinking about focal individuals. And so there's a leader who's used as a selection device. And he argues that this is particularly important when you have rapidly changing landscapes. So like in a military encounter.
Yes.
And he doesn't go into the kind of repeated game analysis that you have. But when we think about animal kingdoms, there often are dominant individuals, who has the biggest antlers or whatever. And I think this fits into with your work on social contract theory, where you distinguish between different time horizons. And so when and this big difference between Harsanyi utilitarian type rules and Rawlsian rules really mattering in the short run when the landscape is changing. And so the emergence of dominant individuals, deferring to a dominant individual might be a norm that's quite natural in many circumstances, as being particularly adaptive to rapidly changing landscapes.
Yeah, well, actually, my position is sort of buried under philosophy, but my position on this is just as you attribute to Shelley. And I think our ancestors, when they were operating as hunter-gatherers, kind of had, at the ultimate level, two choices. There's for picking an equilibrium, and one is fairness, which I wrote various books about, but the other is the case that you mentioned, which is leadership. And David Hume is strong on this. At the end of my discussion paper that goes with this talk, this actual quote appears in an appendix, very important, in 1739. He says, it's a great mystery how tyrants manage to rule large numbers of people, although in fact all the power is with the ruled. So how is it that the leaders manage to do this? It's easy to understand in a guerrilla society that the biggest and the strongest can dominate physically, but what about tyrannical societies of humans? And the game theory answer to that, I think, is simply that what the leader does, he points at a perfect equilibrium. In other words, the social norm delegates to him the choice of an equilibrium, but it has to be an equilibrium because otherwise it won't work. An example I like to give is Alice in Wonderland. You remember the Red Queen, Queen of Hearts, is always ordering people's heads to be cut off. And so the Queen of Hearts says to player one, cut off that person's head. And why should the person told to do it? And the answer is that if he doesn't, the Queen will order somebody else to cut off his head. And if that person doesn't do it, he will be ordered, and so on. And it seems a kind of fragile collection of responsibilities, but the folk theorem with perfect equilibria shows that it can all hold together. This is how authority works. And we need authority for the same reason that you were saying yourself. in rapidly changing circumstances, like running an army, or if you're in a sailing ship in a really bad storm, the last thing you want is to try and solve the problem by democracy. You need someone to make quick decisions right off. And so this way, it seems to me our own social contract is really a combination of fair or democratic social norms and leadership norms. And for many years I tried to persuade my students that they should write on this subject, but they wanted to write on more concrete things. I guess I've no more to say to that. Does it answer your question?
Okay, had to turn myself on. Yes, no, there are these different kind of norms, and they're probably both operating.
It's important that even very unpleasant norms, norms we don't like at all, they still have to be equilibria, because otherwise they will fall apart. And
yeah, that's right, and that they work well in some circumstances.
And
which is what you said.
Very bad in some situations and better in others. That's right. Yeah.
Yeah. Thank you.
Any other questions? Here, Larry Samuelson.
Ken, Larry Samuelson here. Near the end of your talk, near the end, you indicated you want to keep Homo economicus, but you also suggested that to understand Bart Simpson, we had to get into his psychology.
Yeah.
Behavioral economists would argue that what they're doing is precisely combining psychology with economics. I wonder if you think that's a route to progress in this respect.
Yeah, I think about this, Larry. Anyway,
I had a suspicion, but I'm interested in why then.
Yeah, I'm very positive about combining economics with psychology. Okay. And those behavioral economists who do that, I'm with them 100%. And I'm a behavioral economist myself, and so are you, Larry, in that we run experiments. And these experiments necessarily combine economics and psychology. And what I'm hostile to is the section or sector, would be better, the sect of behavioral economists who want to discredit neoclassical economics, no matter what. Okay. It seems to me that neoclassical economics actually works rather well in certain kinds of markets, and in the laboratory it's ridiculous to want to throw that work away. And in particular, the denigrating of Homo economicus. And it is simply false, as behavioral economists say, that neoclassical economics is refuted because people turn out not to be selfish. You hardly need to do experiments to know that people are selfish sometimes and not selfish other times. I mean, how else would we explain giving money to charity? I bet everybody listening now gives some fraction of their income to charity. How are we to explain it? And it's simply false that people's utility functions are just representations of money. And every time behavioral economics paper is published in which a unselfish utility function is fitted to the data, it's a confirmation of neoclassical economics. It's not a refutation at all. It's a confirmation. If their results could be trusted, it would mean that in this particular case, the player's behavior is sufficiently rational that they're behaving as if they're maximizing a utility function. And that's what neoclassical economics says. Unfortunately, you know, the data doesn't fit that. They always have to invent a new unselfish utility function for each new set of data. You know, physicists wouldn't publish such work. So I have a big yes for the scientific behavioralists and a big no for the propagandists.
Yeah, Ken, I'm a bit worried about your coalitions, you know, and I ask myself whether we should start coalitions and then ask whether there are some equilibria in there. You see, in general, if you look at the society is big and the core is empty. And what you have a kind of stabilization sometimes by this kind of threats, counter threats, what you had in bargaining sets, you know. But we have these changes. And I really wonder, you know, whether, of course, we have a theory, you know, about coalition formation, which starts with equilibria of individual equilibria. But I think there's a big gap when it comes to explaining social behavior from the point of collectivities like coalitions and yeah, individuals. I'm just lost in that, you know. I don't ask for an answer.
I'm 100% with you there. I think nobody's going to listen to us. I mean, it's important to understand that. But no, we are in serious danger of collapse of our social, particularly in America, of our social contract, and it's because coalitions can be formed. And you can see a coalition has been formed. There's a big trumpery coalition. And we've got really good reason to be worried about it. And what are game theorists contributing at the theory end? Well, you know, we listened to Larry Samuelson last week, and you know, he was telling us what to do in certain cases if the past isn't an open book, and we certainly need that. But we don't have any decent theory of coalition formation. There are various people write good papers, but you know, are these good models of coalition formation? I mean, chiefly they've been chosen because they're simple and tractable. Because as soon as you get large numbers of players who might be doing different things, of course, it becomes complicated. We don't have a decent model of coalition formation. So what are we supposed to say to people who ask for advice? I mean, I'm just speculating when I draw my I show my pictures from the geography book. I think we've got a lot to worry about, and you know, people like us, younger people than us, perhaps ought to be thinking very hard about these questions, and I'm not sure that they are.
Okay. Well, I'm not sure either. I don't think there's a clear-cut answer. We will have many theories of coalition formation with many solution concepts, and then we pick the one and the other, you know, so far.
We would do it back. People don't read Reinhard Selten anymore. And I think young German economists might think, let's look at Reinhard Selten's old work. There was someone who understood the things that really matter and didn't allow himself to get lost in equations, but always had his hand on what matters. Interesting stuff on coalitions and experimental stuff on coalitions as well.
Okay, thank you.
So probably if no one else has a question at the moment, I can pose one of my probably stupid questions, but if I catch this right, and I just want to ask if I understood it, so social norms help at two situations. One situation is if you have several Nash equilibria or equilibria, and if, yeah, the question is like in a chicken game, so the equilibria are as good as the other one for the other player and the other for the other player. It's very hard to decide which one is the better one or which one to play. And in those situations of several equilibria, social norms could help. And the other situation, and this is for me another situation, is to help to coordinate, yeah, as we had last week as a cooperation. Or is it the same what you mean, Manfred, with coalition? Just the situation of not playing the equilibrium, but the better solution for both, which just needs this coordination. And if I understood it right in your talk, that's what you need, this repetition and unlimited repetition to have.
Coordinate is a really good word, I find. People who are hostile to the idea of equilibrium, and especially when it's introduced in a biological context. But when they're told that an equilibrium is a device to allow people to coordinate, they tend to So I mean, part of our problem is finding the right words to try and widen the class of people who are willing to think about these problems. You think English has got so many superfluous words, you would think we could find good words.
Yeah, like with environmental questions, not to pollute the earth. Isn't this something like such a social norm, which is at the end of the day a coordination, which is not the equilibrium? The equilibrium would be to pollute. That's a pity, and it's a social norm not to do.
When I say coordinate, I say coordinate on an equilibrium. And people listen to the coordinate, and the equilibrium is somehow legitimized by the word coordinate. I guess it is because it carries the connotation that it's voluntary, that nobody is forcing anybody to do anything.
Okay, thank you. So let me be clear. Talking as an ordinary economist to a giant, Ken Binmore is a giant to me. So I apologize for asking a very provocative question. Last week, actually, I learned from the seminar by Larry Samuelson that he found, in my terms, a new solution for the chain store paradox that Dalton has published in 1978. And it is a second answer, so to speak, to the problem of cooperation with incomplete information. The Gang of Four, like Milgram, Wilson, and so on, has published in '82 as an answer that tiny bits of incomplete information may have a solution that sustains cooperation. Now, this week, actually, I learned from you that one should not contrast Homoeconomicus as a very rational, 100% rational human being with the irrational behavior that we can observe even in experiments. But the provoking question is, there is a school, and I may reveal that I studied by Dalton, with Dalton's people, that actually very confirmative have shown that human beings do not maximize, do not form beliefs with probability distributions. So we must look for other ways of behavioral explanations in sustaining what we observe as regularities. And my provocative question is not that Werner Güth, for instance, would say neoclassical theory is what we observe a repair shop for human beings. What we observe with behavioral economics, but that we have to look for a more fundamental revision of the theory. And at the beginning, you mentioned that we have no way for looking at quantum mechanics in order to behave the birds singing in the spring. But now here's my point. Neoclassical theory is, as in many instances, as myself have explored, not a good device for time-dependent dynamical behavior. You look, and this is great as long as it works, at equilibrium theories only. But in many instances, you suggested today, there was so much dynamics in it that it is hard to explain these dynamics by equilibrium theories. So in other words, my provoking question is, what makes you sure that the birds who are singing, and you look at stable environments so far, what do you think, why is it an equilibrium and why is it not an adaptation, part of adaptation that might took some periods, even very long periods, but it is an adaptation, so that you may approximate this behavior by an equilibrium, fine, but you cannot be sure that it is an equilibrium which is in evolutionary terms then something like a bus stop, so where no point of change anymore occurs. But we do observe a lot of variations, not only in singing, but also in the behavior of birds. So my question is, what is your answer to the provoking questions? Okay, you are defending neoclassical theories. I would say, okay, you are defending just equilibrium models, but not the problems you shown today are many problems are not equilibrium problems, but very dynamical out of equilibrium behavior.
Okay.
So someone must be asking a provoking question. This is such a fascinating seminar, so I am excusing myself for talking so long.
Well, I have to admit, I'm a bit provoked. For your attributing, why am I so sure of this? Why am I so sure of that? I'm not sure of anything. You know, how do biologists know that a particular bird, the behavior it observes is in equilibrium? We don't know that. It's they do like physicists do. They try models, and you want to try simple models first. So you try simple models. Does it work? You know, does the data refute the prediction of this model, or does it not? And in fact, the game theory models in evolutionary theory often work very well, and sometimes they don't. And then there's a problem. What have we done wrong? There's a particular paper studying spiders in the Nevada desert. And it turned out that the game theory model didn't predict particularly well. And then people looked at the problem, and you've left certain things out of the game that you've written for these animals to play, to put them in, and then it works. But there's no guarantee that this is going to work. So there's no surety at all. And you know, people who talk about equilibrium in an evolutionary context, they most certainly are not forgetting the dynamics. Their notion of an equilibrium is the end product of the dynamics. And it's very, well, you probably know yourself from your own work, it's very, very hard to study even greatly simplified dynamics you're quickly into systems of many non-linear partial differential equations. And what are you supposed to do about that? Even the model is just an attempt which is not going to fit the facts properly because it's a simplification. We just have to work on what we can work on. And the first thing anyone who studies dynamics does, is mathematicians looking in the abstract, the first thing you ask is where does this go in the long run? And that's the equilibrium. If you don't know that, what do you know about the dynamics? And then you want to add more dynamics. People ask in biology, it's not enough, they say quite rightly, that something be a Nash equilibrium. It has to be locally stable in the sense that if there's a deviation, the dynamics will push it back to where it came from. And this isn't necessarily true of Nash equilibria. So Nash equilibria are just a stopgap. When you're trying to talk in a general way, one says equilibrium, but what kind of equilibrium? I showed you the picture of landscape picture, and I pointed out equilibria in the lakes. Well, they are equilibria, but they're very, very local equilibria. If there's a perturbation pushes you, of course, there are lots of small perturbations, but if you get an incident where lots of them all happen at once, it will be enough to push the system out. So, my answer is just pragmatic. One has to do what one can do. And of course, one would like to do the dynamics if one could. But we don't know how to do the dynamics. There's so much we don't know. And we mustn't criticize, or I don't think we should criticize the work which actually comes to conclusions in simplified situations, because it isn't the solution of some much more complicated problem, because we don't know how to do the much more complicated problem. And as I was taught when I was a graduate student in mathematics, my supervisor said to me, why are you trying to solve this very complicated problem? Why don't you solve something simple first? That was the best advice I ever had. So I guess that's my answer to you, but I know you won't be satisfied.
So then I think it's time to say a very big thank you to Ken for this really great talk today, and to all others also for the contribution to the discussion. And yeah, then let's close for today. Thank you very much again.
Thank you.